Okay, so just welcome everybody to the April meeting. And this, as I was saying earlier, this is the 13th of April, which is one day after Yuri's Night. So this is actually the Yuri's Night talk that we're doing tonight. What tonight Kerrie will be covering, Kerrie Dougherty will be covering, is I suppose you could say that the changes over the last not since
65 years.
65 years. That's a lot of years. How astronaut training has changed and evolved for both sides, and that's the uh, one thing that's worth covering really, because I don't think we've ever done anything like this before actually, and this type of thing. You know, so I look forward to the presentation, Kerrie. So I'll turn it over to you now. We'll see how we go with the.
All right, let's see if we can get this to share again.
Yeah, we'll see if there's any
Where's it
issues.
gone? Okay.
Not yet. Now we've got it. Now we'll just see what
Yeah,
happens when you
and
put it in present mode, whether there's any issues.
sorry, I've just got to get it to go into
No, that's all right. Always
full
stuff before
screen
you
mode.
want to do it.
There we go. So you guys can see that all right? Okay,
Looks all right to me.
Looks
that's
good.
good.
Any
Oh,
issues?
now we'll
Okay.
just go back one,
Okay.
back to the start. Now, full confession, I did this talk yesterday for the Australian Space Discovery Centre, so it has actually been originally created for people with a bit less knowledge of space than most of us here. But uh, I'll try to add a bit more information into it as we go this time. So, of course, this was created yesterday, which was the International Day of Human Spaceflight. And just by sheer coincidence, that happened to be one day after the Artemis mission returned safely to Earth, which, of course, we hope is now inaugurating a new era of space exploration, returning to the lunar vicinity after more than 50 years. Now, I think most of you here know that the International Day of Human Spaceflight, which we used to refer to as Yuri's Night, was formally designated under the name of International Day of Human Spaceflight by the UN back in 2011. So, why is it on this date? Well, of course, this is the day 65 years ago, or yesterday was the day 65 years ago, that Yuri Gagarin made the very first spaceflight. And because it was only 3 weeks after that Alan Shepard became the first American in space. As we know, it was a very close fought and close run contest back there during the space age. Now, or the original space age and space race. Now, of course, the uh, Artemis astronauts and our own Catherine Bennell Pegg and her crew of ESA astronauts all underwent the same basic training. And today, astronauts, cosmonauts, taikonauts, whatever we want to call them, all around the world, effectively have the same basic training program, which is the first phase of training after their recruitment. So certainly all the international partners on the ISS have actually agreed to this minimum set of requirements. As you can see there, should be able to see the cover of the document for that, and I think it was 2006 when those basic training standards were agreed on. So now, whether you're a NASA astronaut, JAXA, whatever, everybody will be trained to that same standard. And you have to get that successful completion before you can then be assigned to the next training phase and be eligible to fly to the ISS, and of course now potentially eligible to fly to the moon on an Artemis mission. But that's now. What about 65, well, in fact, even more than that, 67 years ago, when the first American astronauts were selected in 1959, and then the first Soviet cosmonauts were selected in 1960. I will apologise for the quality of some of these early images, because it's still, even now, not possible to get really good copies of some versions, particularly of the early Soviet images. But at that time, literally when these astronauts were selected, yes, we'd had a few space dogs and space monkeys. We only had the first chimpanzee in space shortly before Shepard himself flew. So we really didn't know how the human organism was going to react to being in space. We knew that people could obviously survive, but there was a lot of concern that the human body or the human psyche literally couldn't cope with the space environment. You know, there was thought that perhaps our reflexes wouldn't work properly, even maybe we couldn't swallow or eat properly. So we literally didn't know what to expect, and for that reason, the astronauts were trained to kind of expect the unexpected and be prepared for the unexpected. But the first part of the training in those very early days was to sensitize the astronauts as well as they could to what they expected the conditions to be. And that actually began with weightlessness training. So we're all familiar these days with the Vomit Comet and, doing the necessary parabolas on aircraft to create short bursts of weightlessness. And this is how both the Americans and the Russians trained in right at the very beginning. So here we've got a couple of Mercury astronauts there on the left. We've got, I think it's Gagarin actually, training there on the right. This is actually, what's his face, Carpenter. And he's in the back of I think it was an F-100 or an F-106 fighter, again doing some maneuvers to generate weightlessness. And you can actually see the little floating ball there. And of course today, weightless training is still, or weightless sensitizing is still a basic part of astronaut training. There's a couple of shots of Catherine Bennell Pegg doing her, or some of her weightless training across her period with the European Space Agency. So it's a way to get astronauts started to get a feel for the space environment that they're going to be operating in. Other areas that, because they weren't sure exactly how people would react to things like being in extremely low pressure environments, they had to get used to the potential, of course, for maybe losing atmosphere on the spacecraft and being able to detect that soon enough before you passed out from hypoxia. So this is in the right at the very beginning, they used to train the astronauts in these pressure chambers or altitude chambers, just as they do today. In fact, here's Catherine and a couple of her colleagues in the pressure chamber at the European Space Agency's Astronaut Centre, getting again used to what low pressure feels like, what lack of oxygen feels like, so that if you have a leak in your spacecraft, you can detect it, if no other way, by recognizing the effects on your own body. But interestingly, during the Gemini program, one of the things that they would do with these pressure chambers is EVA simulation. So I know, I don't know how well you can see that. I couldn't get a good version of this, but this is Ed White, ahead of the first American spacewalk. And what they've done here is evacuate the chamber to create vacuum so that his spacesuit would balloon because of the internal pressure, to get him used to the fact that it was going to be very difficult to move around in space because of that ballooning spacesuit. And we know, of course, that that's what gave Alexei Leonov a lot of difficulty getting back into the Voskhod 2 spacecraft after his mission, which kind of tells us that perhaps the Russians didn't use this kind of pre-training for Leonov. But so there's a lot of other, sorry, I keep trying to flick the wrong button there. There's a lot of other things. Here's Gagarin on a vibration chair, again trying to get them used to the vibration they expected astronauts to feel during liftoff. And this is a rather interesting one. It's a composite photo of Scott Carpenter, actually in a rig that was designed to simulate the different attitudes that you might wind up being in, depending which way your spacecraft was pitching or your, excuse me. So they were trying to really get the astronauts used to a whole range of different sensations they might experience. Of course, we know that in launch and re-entry, you're going to experience higher G loads because of the acceleration and then the deceleration. And so in both the United States and the Soviet Union, um, experience with a centrifuge was part of the training, so that you'd be subjected to anything up to 12 Gs, because these were the expected maximums that you might experience during spaceflight. I believe, and I'm happy to be correct on this, but I think there was some get up to about 18 Gs on the centrifuge, just to see how well they could cope with it. And one of the interesting things they used to do as well was to actually mock up the interior of a centrifuge with the control sections of the spacecraft, so that, again, you would get used to trying to operate the controls of the spacecraft during launch and re-entry when you'd be under those additional G-force stresses. You can see over here on the right, this is the training centrifuge they use today at the European Space Agency, and below it is the Mammoth training centrifuge the Russians have been using since 1973. This is the largest human centrifuge in the world. And I've actually been in that room with that centrifuge. I haven't been in it, but it is really, astoundingly big when you're standing there. They nickname it the monster or the mammoth. The other one you see here with the rather lovely wall graphic of Yuri, this is another interesting training one that, again, they have mocked up as the interior now of a Soyuz spacecraft, so that, again, you can practice operating the controls while you're under the sort of G-forces that you might expect through launch and re-entry. So very similar training even today, still to get you ready for what you're going to experience in space, or getting to space and returning. But particularly in the early days, one of the things that they really weren't sure about was how well an astronaut might be able to control the spacecraft that got out of control. How could they get it back under control? And this was particularly a concern, would they be too disoriented to be able to calculate and operate the necessary little retro rockets, or control rockets, I'm sorry, to bring the spacecraft back under control. And this is a particular issue with both the Mercury and the Gemini spacecraft because of their sort of cone-shaped construction with the sort of neck that they had at the front of them. And so they developed this amazing thing called the Mastiff, the multi-axis, I can't remember all of the acronym tonight, you can look it up, but the multi-axis trainer that was designed to literally spin in all different directions, simulating a spacecraft out of control. And then they used small nitrogen thrusters that the astronaut had to practice getting the spacecraft back under control while they were in this wild spinning pattern. And in fact, that kind of training stood Neil Armstrong in very good stead during the Gemini 8 mission, when, as some of you may recall, a stuck thruster was forcing the Gemini 8 spacecraft, even after it undocked from its Agena target vehicle, to rotate and pitch and yaw quite wildly, so that Armstrong was eventually able to get it back under control. Now, the Soviets didn't have anything quite as sophisticated as the Mastiff, but they did do some disorientation training with this lovely swing that you see here, which would swing. If any of you remember those old, they were like a long swing board that you would sit on, and maybe 3 or 4 kids would all get on there and swing back and forth, but if you moved around, you could swing it sideways a bit. So they used that's Valentina Tereshkova there on this disorientation swing. And this is quite interesting. This is like again, that kind of swing that used to have the metal bars, and you could get really high if you swung yourself standing up, backward and forward. But you'll see it's got a knuckle here that enables it to rotate as well. And so you could be swinging wildly back and forth and suddenly find that you're also rotating around. So again, you had to try and get yourself under control. But fortunately, the later designs with the Apollo spacecraft, and more recently, of course, with the Orion or Crew Dragon, that type of gumdrop or cone shape that they have is a lot more stable. You don't tend to get that really wild spinning that you could get with Mercury and Gemini. Of course, the Russians in the um, very earliest days had an additional type of training that wasn't needed in the West, because as many of you who've heard my previous Yuri's Night talks will know, at that time the Soviet Union didn't admit to it, but because of the concerns that the spacecraft retros couldn't completely slow the rocket down, the capsule down enough to ameliorate the landing shock on the ground, that the cosmonaut would actually eject at high altitude and parachute down separately. So parachute training was a big thing for the original Soviet cosmonaut team. And of course, when they selected the women for the 6 women, 5 women for the original astronaut female cosmonaut team, they were selected. Unlike the men, who were all military pilots, they were selected because they were all champion parachutists. And that was what they really needed to be able to do in order to bail out of the spacecraft, because the Vostok was essentially a remotely controlled spacecraft. The cosmonauts had much less ability to fly it in the same way that the Mercury astronauts could. This is actually quite an interesting photo. This shows the ejection seat, and you can see this is what the cosmonaut would look like sitting in it in his spacesuit. And there's Gagarin there. That's Titov there beside him. But this was the so-called Vanguard group. These were the cosmonauts who were considered to be the leaders out of the 20 or so that were originally selected. Now, they were bailing out as part of exiting your spacecraft is something that was only ever considered in the NASA program on one occasion, and that, of course, was when they created one of the emergency escape systems for the space shuttle. Following the Challenger disaster, there was a lot of talk about the fact that effectively the astronauts had no way to get out of the space shuttle if it encountered problems on the way to orbit. And so they developed this long pole system that would extrude out the hatch of the shuttle while it was, potentially coming back down to Earth, or drifting, I shouldn't say drifting, but falling back down to Earth with perhaps an aborted launch. And you could jettison the hatch. They'd extrude this long pole, and then the astronauts would theoretically slide down this and bail out from there, operating their parachutes. They needed to get that extension to get them away from the wings of the shuttle, so that when they fell free, they didn't fly back and hit into the wings of the spacecraft. That's the only other time that any thought of bailing out, in a sense, has been used. Of course, we do know that the Gemini astronauts and the first couple of space shuttle missions used ejector seats. But of course, as military pilots, they were already familiar with how to use ejector seats anyway. Health and fitness was very important to the early astronauts. John Glenn was famous for running 5 miles every morning. The Soviets the same. They had their cosmonauts doing a lot of exercise, a lot of calisthenics. Survival training was also very important, because if you had a problem with the spacecraft, you might have to come back to Earth early. You might not land in the expected landing area in the ocean. So the Americans did a lot of desert and jungle survival training, and this is the the original Mercury 7 after their 3 days of desert survival training in the Nevada desert. The Soviets, of course, normally tried to bring their spacecraft down on within Soviet territory, but they practiced emergency water landings, and this is actually Valentina Tereshkova doing her emergency water training, some of her emergency water training. And this is what the astronauts still do today. These are some shots from Catherine Bennell Pegg's training. They do different types of water escape training if their spacecraft perhaps came down upside down or began to leak and they needed to bail out. They've done winter training. This was something that was also very important for the Soviets, even in the early days, and of course they still do it today. Because if you come down off course in the Kazakhstan steppes, you might wind up in the wintertime in a rather precarious situation, which happened to. I'm trying to remember the crew, but they came down off course in the sort of snow-covered forested area. I think it was about 18 hours or more before they were actually located by the recovery teams. So that's been a very important part of this survival training. But in addition to that, today the astronauts also do things like firefighting, rescue work, and this is intended not just to equip them with survival and first aid type of first responder type skills, but also to build their leadership capabilities, their confidence in their own abilities to handle a whole range of situations. So it's all part of the broader capability training for the astronauts today. It's not just about survival for its own sake. As we know, of course, the American spacecraft, apart from the space shuttle, have always landed in the water, and right from the beginning, evacuation training has been very important to the astronauts. So I love this photo. This is John Glenn making an emergency exit out through the top of the Mercury spacecraft. Normally, of course, the astronaut would exit through the side hatch, like we're seeing Carpenter doing here. The Apollo astronauts, of course, just like Artemis on Saturday, they would normally escape through the or exit through the side hatch. So you had training for that. You've still got training again for the Crew Dragon, similar thing. You're exiting through the side hatch. So all of them have got these water escape training. Something that's interesting now is the both NASA astronauts and the European astronauts and JAXA. They all practice as well. I'm sorry, the Russians do it as well, but they all practice helicopter underwater escape training. And the reason for that is to get them, again, accustomed to how they would need to react in the event that your spacecraft came down and began to sink rather than floating on the surface as it should. So this was to get them used to that idea of being underwater and being able to cope with escaping from a flooded or flooding spacecraft. So the concept has continued right through because you've got the spacecraft still doing the same type of thing. They're still landing on the water. The shuttle, of course, is a different kettle of fish because it landed like an aircraft. You would normally escape it somewhat like an aircraft, so they'd have the same type of slides for the astronauts to come down, but you could also escape out the top through the hatches on the upper deck. And so again, there was a training for being able to do this bit like a rappelling down the side of the space shuttle in order to escape. In the event that the shuttle did come down on water, which was something you really didn't want to try and do, they did also do some water escape training as well, but I couldn't get a really good picture of it. The Russians, of course, even though, as we know, they land on the land, normally if they came down in the water again, they're still today doing this kind of water evacuation training so that they are prepared for that possibility. And in the lower shot here, you'll see this is rather interesting. He's wearing a Pharrell suit, that orange suit that he's wearing. And it's designed if you come down in, particularly freezing waters, what you would do if you have the time in your Soyuz reentry capsule is that you would get out of your so-called suit, out of your space suit, you'd put on a cold weather suit, and then you'd put this orange Pharrell suit on over the top of it, which was designed between the two of them to keep you for as long as possible from developing hypothermia in really freezing waters. And of course, that was a possibility or still is a possibility if your Soyuz spacecraft comes down off course and perhaps winds up somewhere in the Arctic Ocean. Of course, when you're launching on what is essentially a controlled bomb, you also need potential ways to escape in the event that something goes wrong. Now, of course, the Saturn V, the Soyuz, most spacecraft, apart from the shuttle and the Crew Dragon, they have a launch escape tower to get you away from the spacecraft and to pull you away. So that's a case you can't so much train for that in the way you might have to train for other areas. Obviously, whoever's operating the abort handle does. But interestingly, initially the Apollo program, in Gemini, if you had a problem on the pad, you were still expected potentially to use your ejector seats. But during Apollo, if you had time, there was the possibility to escape from the spacecraft, take the lifts down to the base of the launch tower, and actually slide down a chute. You see here, and you got into what they called the rubber room. And essentially, this was like a bomb shelter buried below the launch pad. And they called it the rubber room because it was actually mounted or completely surrounded by rubber shock absorbers. So it was like an armored room surrounded by rubber shock absorbers, so that if the Saturn V blew up above you, you would be as cocooned as possible from the effects of the shock. And this is a photo inside the rubber room. I believe it was finally demolished during the refurbishment of the pads for SpaceX use. So, in the last few years. But that was intended to be your emergency escape. And of course, you had to practice that, just as in the shuttle period and even with Artemis now. If there was a time for you to escape from the spacecraft when there was a problem on the pad, what you would do is exit back to these escape baskets. And you can see here on the left, that's the type of basket they used in the shuttle. And they're a shuttle period, they're a bit like a gondola. They would literally then slide down a long cableway that took you several hundred meters away from the base of the launch tower. And then in the shuttle period, you'd get into this. There was usually a couple of these armored personnel carriers that were parked near the base of the wire run, and you'd jump into those and hightail it out of there if the shuttle was going to explode. And pretty similar with Artemis, this gondola type arrangement comes down the big long carriage wire, and there's a similar kind of heavily armored vehicle waiting at the bottom to take you away from any danger. The interesting one, I think, is the what they use on the Dragon. You can see it has inbuilt thruster, so rather than a launch tower, it has this set of inbuilt Super Draco thruster engines that push it away from the body of the spacecraft. And this can be used either on the pad or for an abort in the early stages of flight. The photo there is from an original ground test that they did at Kennedy, where they actually fired it from the ground to make sure that the concept worked and that it would land safely. Now, another aspect of astronaut training, of course, was the what we call classroom training. So the astronauts, apart from Glenn, all had degrees in engineering or physics. Some had both, and so they needed to understand their spacecraft fully. They needed to understand what was really happening in the environment that they were going into. They needed to understand celestial navigation. So there were a number of different classes or courses that they would go through during their training. And it was the same in the Soviet Union as well. So we've got the Mercury astronauts here. We've got the some of the original Soviet cosmonaut team here. I don't know how many of you will recognize this as Konstantin Feoktistov. He was both a lecturer for the cosmonauts, but he was an engineer. He was also one of the designers of the Voskhod spacecraft, and then he became a cosmonaut in Vostok 1, Voskhod 1, and in fact Khrushchev essentially ordered that he be one of the cosmonauts because if his life was on the line, Khrushchev figured that he would make sure that this spacecraft was going to return from its mission, because for those of you who don't remember, Voskhod 1 was a Soviet attempt to pip Gemini in a multi-person spacecraft. And so what they did essentially was to, as we discovered many years later, was that they stripped out, the Soyuz wasn't ready, so they effectively stripped out most of the interior of a Vostok and put crammed three seats into a Vostok for the cosmonauts and just renamed it the Voskhod. But so it was a very risky mission, and so Khrushchev wanted Feoktistov to be part of it to make sure that he would give the astronauts the best chance to survive. But again, whole range of familiarization with the spacecraft. Here's Tereshkova and some of the other female cosmonauts, examining some of the control instrumentation. We've got another interesting thing was that they did want the astronauts to understand how their physiology worked, so again they could understand and report on any changes that they experienced during spaceflight, because, as I said, we really didn't know at that point how the human body would be responding. So here's Wally Schirra getting a lesson in human physiology. And these were just, a variety of the courses that the astronauts were undertaking. Now, today, during their training, astronauts are studying biology. They learn to understand medical sciences, how to take various measurements of their own bodies. Of course, they're studying astronomy, earth sciences, meteorology, all of these areas, because if they're on the ISS, they could be responsible for a whole range of different experiments. And so they need to really have a strong grounding in the variety of different sciences that they might be asked to interact with or oversee or take observations for. So it's a much broader and much deeper scientific background that the astronauts need to acquire today. And these will all be relevant again too, ultimately for research on the moon. Familiarizing yourself with your spacesuit was quite an important role in the early days. You needed to be comfortable in wearing it, to understand how it worked, to make sure that you could move properly in it. Spacesuits can be quite restrictive. So all of the astronauts and cosmonauts would, be fitted in the early days, especially. They were all custom fitted spacesuits. It wasn't until the space shuttle that you started to get things like the EMU, the extravehicular mobility unit, which essentially was came in 3 standard sizes. So it was almost one size fits all. The so-called suit that the Soviets and the Russians use is a bit the same. It comes in a couple of standard sizes, but it has a number of laces and little pulleys and things inside it that you can then adapt specifically to your own size. But particularly in the early days, and again now, the Artemis suits are all custom made for the crew. So getting to spend time in your spacesuit, to train in your spacesuit for all your different tasks, has been and remains really important. Say particularly too with something like the EVA suit or the Orlan, which is the Russian EVA suit. Getting into them is difficult, so you need to practice it on the ground again, so that you'll be better able to perform in microgravity. And I threw this one in. This is Catherine trying out a prototype for a new suit over in the US when she was visiting as part of her astronaut training. And well, you guys all know how you go to the toilet in space, so I don't really need to explain this to you. But for those of you who haven't seen it, this is down the bottom right here. This is a picture of the Artemis space toilet. But essentially learning how to operate things like the galley, the space toilet, all the equipment on board the spacecraft has been and remains something that is absolutely essential. But that would normally be part of your second phase of training, depending on which mission and therefore which spacecraft you would actually be assigned to. Food is another essential, and from the Apollo days onwards, it was actually possible for the astronauts to start taste testing some of the food. Initially, not all of it, but nowadays the astronauts can taste test the range of the menu so that they know what things they like and what they don't like, and that way they can then customize their own menus. During the Apollo-Soyuz mission, this was the first time that the Soviet cosmonauts got to try out American space food, and the Americans got to try out Russian space food, so that again they could decide which menu items they liked. And of course, as we know today, Russian and American space food, and indeed Japanese or French or space food from various countries is carried, and it is possible for the astronauts to do a little bit of a mix and match, the crew to do a bit of a mix and match, so that the Russians don't have to eat only Russian space food. They can do some swaps with the Americans, or they have some quantities of American space food and vice versa. So it's still a case that the Russians and the Americans will try out both countries' space foods to see what they like. The thing, of course, that we understand now, which in the very early days they didn't, is that being in space changes your sense of smell. It also changes your sense of taste. And sometimes something that you decide you really like on Earth, you discover that you don't like at all when you're in space. There have been a few instances where somebody has really liked something on Earth and loaded up their menu selection with that item, and then discovered that while they're on orbit, they just didn't like it at all. It tasted so different to them. So that's an interesting one. Of course, the spacecraft always carries spare supplies, so that you can do a bit of a swap out if you discover you really don't like something. Training to understand your spacecraft is, of course, really important. A lot of work, especially in the early days, was focused during training on, completely comprehending every control, what it did, how it operated. And you would do this in simulators of various types, apart from that training that I mentioned earlier in the brain's just gone dead. Sorry, it's just completely gone out of my head. In the centrifuges. So you do that kind of training to really get the feel for operating a spacecraft under high G accelerations, but you'd also be practicing it at, well, 1G, but just to get the full understanding of the layout so you could almost automatically know where everything was in the spacecraft. So these are a few images of the kind of simulator that they were using in the Mercury days. This is the Voskhod. This is actually the Voskhod 1 simulator, and you may be able to see how closely packed in the seats are there for the crew. This is an interesting one. This is a twin simulator that they were using in the early days of the Soyuz joint missions, so that you could have two cosmonauts at the same time actually practicing their rendezvous. Of course, this type of simulation continued through Apollo. This is actually Phil Chapman. Some of you may know his name. He's in the lunar module simulator here. Chapman was one of the earliest scientist astronauts, and he was the first Australian-born person to be selected as an astronaut, although he never flew. When the Apollo program was cut back, he decided to leave because he didn't want to be out of his scientific specialty, staying in NASA until the shuttle program. But, these kinds of physical simulators were really important right through Skylab, of course, in the space shuttle period. They had a number of different simulators. This one that you can see on the right is literally the launch simulator. So if you were in there, you'd be lying on your back, just as you would be at launch. One of the cockpit simulators, they had what you might call fixed simulators for familiarization with all the cockpit layout. They actually had simulators mounted on different kinds of movable mounts, so that you would get they could create different conditions for the crew, and give them the whole range of experience that you were likely to have. Of course, the interesting thing with the shuttle was that they adapted some of the astronauts' T-38 trainers to operate as if they were the space shuttle, so that they had to be controlled, or they gave the same feeling as flying the space shuttle. And this was a way for the astronauts to learn how to land the shuttle, because as we know, it had no engines, so when you're coming in, you've only got one chance at landing. And the shuttle, flies like a brick, as somebody once described it. So it did need a fair bit of understanding that you were not flying an ordinary plane. Especially like the early astronauts, as we know, they were all test pilots. So NASA decided early on that so that they could keep their flight status in their military ranks, they would provide aircraft for the astronauts, and this way they could also fly without having to be dependent on commercial travel between the different companies that were making the components of the spacecraft. It gave the astronauts a lot of mobility that NASA deemed quite important in the early days, and still today. They maintain in fact, they're still using the T-38s for astronaut transport. Excuse me. In fact, it's interesting. These aircraft, well, not these specific ones, but the design is now about 60 years old, and it's still a really good, just subsonic aircraft. So NASA finds them extremely useful for the pilot astronauts to maintain their flight proficiency, and it also means that the non pilot astronauts, so like Andy Thomas or Catherine, they can ride in the back, but they can also get from A to B very quickly with the pilot astronauts. Physical, as I mentioned, the physical simulators have been continued to be used for training right through the Soviet space station, Russian space station period. This is actually the Soyuz 1 simulator trainer. If you ever manage to make it to Toulouse in France, you can see this is an original Mir full-scale simulation trainer that's now at the Cité de l'Espace Museum in Toulouse. This is in the background here. You can see the Soyuz trainer. You see it again here. That can be used by the American astronauts who might be flying Soyuz in their training. And it's also used for general familiarization for the astronauts. Interesting, these types of large movable physical simulators were very important during the Gemini and Apollo periods for practicing rendezvous and docking, practicing in space maneuvers. The other thing that was interesting, we now think, of course, of if you're practicing for a spacewalk, you would do that underwater in one of the big pools that we'll see in just a minute. But in the early part of the Gemini program, they were actually doing spacewalk training in the KC-135 in a Vomit Comet. So they would actually try to do them in the weightless environment. But you can see it could be quite awkward. And they found that it didn't really equate to, oddly enough, to the kind of conditions that they needed to understand when they were in space itself. And it was actually Aldrin who came up. Actually, I'll go back for a second. This is Aldrin here during his training for Gemini 12. And he was finding it sometimes very frustrating doing this zero-G training. And the previous astronauts who'd attempted spacewalks, that had fairly complex tasks involved, none of them had really been able to complete those tasks. And Aldrin, of course, was a very keen scuba diver. And he thought that the underwater environment would potentially make a better training environment for learning how to perform tasks during spacewalks. And so he persuaded NASA to do some initial experiments for Gemini 12 with training in a large tank. And this was found to be so successful that NASA then adopted it as a standard procedure. So these are some shots of spacewalk training during Apollo, some of the early Soviet spacewalk training for their space station missions. And of course, today we have the Neutral Buoyancy Lab, which is at Johnson Space Center, and the Neutral Buoyancy Facility, which is at Marshall Space Flight Center. And both of them are used for astronaut training. Under the water here, you may just be able to see the some lighter shapes. That's actually a complete replica of the Mir, I'm sorry, there's a flashback, of the International Space Station, so that the astronauts can train on any part of the ISS, as it were, to do whatever kind of spacewalk is needed. At Marshall, they tend to do specialized training for things like, this was the repair work on the Hubble Space Telescope. This was some early training, you'll see by the fact that it has NASDA on it rather than JAXA. This was some early training for the International Space Station assembly. The European Space Agency also has a big training tank. The Russians still have theirs. And Catherine is in the blue flippers there doing some of her initial scuba training with ESA. Excuse me. And again, if she was training for a specific mission, she'd either be, or more likely be with NASA, or she might be training in the facility in Moscow. But it's still very much a part of the necessary training for any kind of EVA work. This doesn't mean that NASA stopped using the KC-135s for astronaut training, apart from the familiarization with microgravity. So here we've actually got the Apollo 14 crew trying out the MET in weightlessness, just to get a feel for how they'd be able to pull it along on the lunar surface, practicing for setting out a particular instrument. And here's another one where they're trying to unfold, or practicing to unfold the lunar module when they get it down off the side of their LEM. So it was still very much a part of astronaut training. Of course, there was also other rather interesting attempts to try and simulate 1/6 gravity. This is a rig that was hung off this giant gantry at Langley, NASA Langley. And the idea was that you would be walking, you'd be suspended in such a way and balanced in such a way that as you walked along this wall here, you were effectively experiencing 1/6 gravity. Similarly, training to land the lunar module, you had this simulator that was suspended on what was effectively a giant bungee cord, and the astronaut would be trying to get the feel of landing on the moon, and how that they would be able to navigate across the lunar surface as they got closer to the surface. Of course, you guys will all be familiar with the lunar lander training vehicle that almost cost us Neil Armstrong. This is a shot that was taken just literally seconds before he bailed out and his vehicle crashed. And apparently he went back to the office, wrote up a report, didn't even tell anyone initially that he'd been in the crash. That's the kind of very cool engineer that he was. But this was, of course, for specifically getting the feel for flying the lunar module itself, because you'd have to fly it over the lunar surface and then bring it down to land. Helicopters were also used for this kind of training, and the Artemis astronauts are already using helicopters now for training again to land the Starship or whatever other vehicle ultimately gets used as a lunar lander in the very rugged terrain at the South Pole. So NASA's already thinking about how they're going to train for future landings. Excuse me. Virtual reality, of course, has now replaced a lot of that physical simulation that used to be done. These are just a few shots of some virtual simulations for training at Johnson Space Centre. Now, this is interesting. There's an Australian company called Ray Tracer, and they've developed a VR system that NASA uses in conjunction with training underwater so that the astronauts can see very detailed, specific visuals of a task they might have to perform on the International Space Station. For example, while they are in that simulated microgravity environment of the water. They're using VR itself on the International Space Station now. This is an experiment that has been done not so long ago with controlling the Canadarm, the remote manipulator, by using virtual reality. So that's something that they're looking at. There's a number of VR experiments that are being done to evaluate astronaut perception in different ways. And again, this is Catherine trying out some VR training facilities at the Thales company in Italy. Still, this is a very new technology. I'm quite sure the Apollo astronauts, the Gemini astronauts would have loved to have it. And it's definitely something which is increasingly becoming part of astronaut training. Of course, for some things like exploring the lunar surface, you still, nothing beats training on the ground, especially for geology and for trying out the simulator versions of, in this case, the lunar rover. But again, at some point in the future, there'll be some kind of vehicle on the lunar surface that the astronauts will want to try out in something more than a virtual reality setting. So I'm sure we'll see this kind of thing again in the future. We've already, again, seen the Artemis astronauts. They've been doing training already in Iceland, basic geological training, both to identify formations and rock types, and also to get used to handling geological picks and other tools. This is actually the Artemis 2 crew and their backups. Now, of course, we know Artemis 2 didn't land on the moon, but it was actually very important training in enabling the astronauts, particularly as they were going around the lunar far side, to identify a lot of the geology much better than the Apollo astronauts did in their day. And if you were listening to, some of that live discussion, you would have heard the astronauts actually talking about, what they thought particular rock types were over large areas and this sort of thing. So this is something which, of course, will continue to be part of future training as well. Some of the other training that the astronauts are doing today, both for long duration missions on the space station and ultimately for long duration missions on the moon and onto Mars, are things like medical operations. We know, the further away you get from Earth, the further away you are from any help in the event that something goes medically wrong. We've already seen, earlier this year they had to bring Mike Fink back from the International Space Station because of some medical issue that he experienced. If that happened on the moon, you'd be 3 days at least back to Earth. If it happens on the way to Mars, you could be several months. And that isn't going to happen. They're not going to you can't just turn around and come back if somebody has a medical problem. So the crew have to be able to function effectively as paramedics, and they actually have to be certified to a particular level in order to be able to perform different, not just medical procedures for taking the kind of specimens that scientists want back on Earth, but obviously then to be able to work under the instruction from a space medical professional back on Earth if there's a necessity for some treatment on the International Space Station before you can get somebody back to Earth for treatment, or obviously if you're on the way to Mars, whatever medical treatment is needed is going to have to be delivered by the crew. So this is now all part of modern astronaut training. Language certification is important because of the relations on the ISS with the United States and the Soviet Union and other countries as well. The main language, of course, is Russian and English. So all the ESA and American astronauts have to be fluent in Russian to certainly a conversational technical level so that they, for any issues, technical issues, they can be directly discussed with the Russians. And similarly, the Russians have English language proficiency. And in fact, that began with Apollo-Soyuz, and this is, excuse me, this is the Apollo-Soyuz crew in Moscow actually doing their English language training. And of course, we know that on the space station these days, a lot of things are marked in English and Russian, particularly the space food. So that whether it's Russian space food or American space food, it's labeled in both languages so that you can know exactly what it is and what you need to reconstitute it for your dinner or whatever. A few of the other things, just quickly to finish off, that astronauts today is part of their training, whereas back in the early days, particularly, the astronauts just kind of had to learn it on the run, and that's things like outreach and public relations. That's a huge part, particularly of NASA and ESA space programs these days. So that, and then these are all shots from Catherine's training. They have to know how to handle cameras, how to take photographs that can be used for both scientific purposes, but also for social media. And they have to be skilled at public speaking and handling the media. So this is all part of training these days. And just to finish off, the career for an astronaut now has a particular training flow. You begin with the basic training that Catherine has already undergone. Once you graduate from that, you go from being an ASCAN, an astronaut candidate, to being an astronaut. At that point, then you're waiting your flight assignment. Now, you could wait several years. If you're very lucky, you might only wait a few months. And during that time, you'll have other duties that might be scientific or engineering work, it might be promotional work, it could be support to other astronauts who are in their in training for their particular flight activities and so on, other professional development work. Once you get a mission assignment, of course, then you'll get specific training relevant to that mission. Obviously, you'll conduct the mission and then come back to your post-flight activities. But as this slide says, most of an astronaut's career is on Earth with ongoing learning and training, because in fact, you have to be so highly trained and you have to keep reinforcing those skills over and over again while you wait for a mission. So thank you very much.
Excellent, Kerrie. I'll just take questions now. I'll see that.
Just let me stop sharing there.
No probs.
There we go.
Yeah, you can go back if you need to specifically go to slides. Anybody got anything they want to ask directly, or are we just putting?
There's a few. Is that questions in the chat or just
No,
chat?
I made a comment about the hot sauce and Tabasco bit because
Oh, yes.
it's quite common that it seems to be that they do like the hot sauce because everything goes bland.
Yeah, well, this is it. Because your sense of taste changes, and very often you don't have a lot of sense of taste. So yes, the astronauts, they like sriracha, you know, Mexican hot sauces.
Yep.
They like to put chilies into food. One of the things they grow on the space station is chilies, and they will cut them up and put them into their food. Things that will get some flavour to them. I see Tom's got a question.
Hey there, I just wanted to mention that I think Scott had one in the chat, but I'm gonna scoot in before you, Scott.
All right.
So I had a question about thanks for the presentation, Kerrie, but I had a question about the escape pole. So
Mm.
I've seen that mentioned a couple of times. I've never seen a photo of it from the shuttle, and that photo looked like it was
It
basically
wasn't from the shuttle. It was a
ah,
training
it was
photo.
a training photo. Okay,
Yeah.
so it was never tested. It was just theorized.
To the best of my knowledge, they never tested it. No, I'll rephrase that. I have seen some photos of the hatch open with the pole sticking out of it,
Okay.
but these were on the ground tests.
Yep. Okay. Okay.
I, to the best of my knowledge, actually, a lot of the astronauts were terrified of the possibility of having to do it,
Yeah.
just because they were really afraid of that possibility of falling back and hitting the wing or something.
Yeah.
There was, it was considered a very dodgy way to have to escape the shuttle. It was very much what's the word I want here?
Hail Mary.
A Hail Mary, yes, thank you very much. That'll do.
Well, it's pretty much like
Something that at least they could pretend that they were giving the astronauts a way to escape.
Yeah.
Yeah,
It,
yes, that's
yeah.
right. Wayne's just saying there the pole was tested on an aircraft.
yeah, it was tested on a similar aircraft, but I mean they tried to make it like that, but it was never actually tested on a shuttle.
No, that's right. That actual shot, that's the only time I found that actually when I was putting this presentation together, and that's the first time I've even seen that shot.
Yeah.
Um, there isn't a lot of stuff around about it. Although there are the couple that I saw where they had the shuttle on the ground with the pole partly out. I did actually find those on the NASA website, on the NASA image website. And I was actually a little bit surprised when I did find them because I was looking for something completely different when it came up. But yeah, so it was never, well, obviously never used in anger, but also never used even as a practice. It was very much a last ditch thing if you had no other way to escape, and it was pretty obvious that the shuttle was going to crash.
It was part of the return to flight business. They actually came
Yeah,
up with a bunch of initiatives, and obviously they had to try to tick the box on that to try to get back in that. And that was really where that came from. Okay, so Scott's
Yeah.
question was
Thanks.
if there was a problem with
No worries.
Saturn at launch, how long would it take to get to the rubber room?
This is a very good question. I would say probably several minutes, because you'd have to come down in the elevator, so you'd have to come down in the lift, then you'd have to go down the chute. I don't know what the timing on it was, but it took a few minutes to get from the bottom. They were not high speed lifts. I have been up in the lifts on the pad for the shuttle, and they were not high speed lifts. So you were not zipping up there like you were going to the top of Centre Point.
Yes, he's got some concerns.
It was the speed of the lifts, which was actually the reason I asked the question, because if there's some sort of red light or something flashing inside the inside your capsule, by the time you open the door, get out, push the button, get down, the Saturn V's probably exploded well before you get to safety.
Well, this is it. You may not get there.
Yeah.
You might even decide you'd be better trying to operate the launch abort system and go that way instead. But theoretically, if you had the time to escape, you would come down in the lift, go down the chute into the rubber room. I should say that picture of the chute, that's the only one I've ever seen of that. I've seen a few pictures of the rubber room, but that picture of the view down the chute, I've only ever seen that one, which I'm glad I grabbed because it's not on the NASA website, the NASA image website now. It says the radiation environment on the ISS. No, the radiation environment on the ISS is exactly the same as a Mercury or a Gemini or a shuttle mission, because you're still inside the Van Allen belts. So it's a completely different radiation environment once you're outside the Van Allen belts.
So radiation then remains a major concern for a Mars voyage.
Still an issue, absolutely.
Yeah.
And in fact, and Eva, you'll know better than me on this. Didn't Freeman Dyson write something a few years ago about why it wouldn't be possible to go to Mars or to come back from Mars because of the radiation environment?
I'm not sure about Freeman Dyson doing that, but I know quite a number of my space physicist friends say that it is laughable, that the amount of radiation that one would expect, lethal.
Well, this is what. Sorry, go on.
In some sense, it's a joke that Musk and so on just keep on blabbing about it.
Yeah, well, Elon just blabs anyway. But I mean, that is why they have been developing things like the these radiation body, torso shields and things like that. There's one down at the University of Wollongong. What's his name? Rosenberg?
Yeah, Anatoly Rosenfeld.
Rosenfeld, that's it. Yeah, nice chap. I've run across him a few times. He's very nice. Yes, he's developed the AstroRad. That's the one, which is like a body shield that you wear. But you wear it a bit like body armor. And in fact, that one's been specifically designed for women because obviously, there's more potential for damage, even if they find some other ways to moderate how much radiation you're exposed to. Women have more sensitivities in that area because of their role in childbearing. That's right.
Yes.
There was.
I had a little question about taste.
Sorry, say again.
About taste. I have a question about taste. You said that things taste a lot different often in space. And I was wondering how much of that was because much of our taste is actually smell. And on the space station, etc., they want to reduce the number of small particles of food or sensory molecules. So is that considered to be the major part of the reason?
Well, certainly the taste issue is the smell issue, yeah, because smell is a large part of your sense of taste, as you say, and because the your sense of smell changes in space. And I'm not sure if
Well,
they
it's meant to
actually
smell
know.
bad, isn't it? It's not meant. I mean, if
Yeah,
you
the food
plunked any
doesn't
of us
necessarily.
in the space station, it would smell pretty bad, pretty ripe to the most of
It
us.
will certainly. I'm not so sure about the
that's a
ISS, but
different
I do know that Mir apparently smelled pretty ripe. That's why they have really good ventilation on the space station.
No, just
But
open the windows.
sorry, open the windows. Yes,
Sorry, that was
but
very naughty.
what was I just going to say? That's an interesting thing with that too. Because of the the air circulation systems they use, you can't wear any perfume on the space station. You can't have any perfumed, uh, you know,
Clothes or deodorants or
deodorant. Thank you.
whatever.
That's the word I was trying to find. Yeah, like roll-on deodorants or anything like that. You can't have anything that might put scent molecules, for want of a better word,
Right.
into the environment. Particularly because there might be an ingredient in them that someone turns out to be allergic to. Somebody just may not like the smell. And if it gets into the air circulation system and is circulated around the space station, that might make some people very unhappy. So everything has to be, totally unscented,
Unsullied.
non-aromatic. Put it that way. But just generally in space, like even in the Apollo, even in Gemini, the astronauts did complain that they didn't have a lot of sense of taste. Now, admittedly, their food probably didn't have that much taste to it anyway. But it's always been an issue and as you say, because the sense of smell is affected. And that's partly affected, of course, because of your sinuses all getting blocked up with the
Lied out and so on.
with the fluid coming up into your head and everything. So all of those things combine, and it just means that things will sometimes, like some astronauts have said, they just taste different. And I know I think it was what the Americans call swordfish. And that for a while, the swordfish steak was on the menu, and it would usually wind up coming back, most of them uneaten. Even though people had liked them on the ground, they just didn't like it in space for whatever reason. And apparently it did actually sort of taste off for some reason. There was back in the, I think it was the late Gemini days or early Apollo days, there was a thing called the strawberry cube. And this was another one that was infamously bad. It was supposed to be like a dessert. And I gather there were so many strawberry cubes that didn't get eaten that there was a point where NASA was encasing them in lucite and giving them away as special souvenir gifts. I've seen pictures of the strawberry cube in the lucite. But apparently, again, they didn't taste too bad on the ground, but they tasted horrible in some way. Well, the astronauts didn't. Might even have been the texture with it, but they definitely didn't like it in orbit, so they didn't get eaten very often.
Do you know how many of the commercially available space foods that were marketed to the public were actually
really used,
like the space food sticks and Tang?
Oh, space food sticks were absolutely.
Yeah.
They were created.
Yeah,
I mean, space food sticks were actually created for the astronauts to have in their spacesuits while they were walking on the moon.
right?
So they weren't introduced with Apollo 11, but I think around Apollo 16 they were introduced as literally if you there are some photos where occasionally you can see there's like a little holder just inside the neck ring.
They're eating them.
And that's where they would put their space food stick, and then you could sort of just suck on it or chew on it while you're out working on the lunar surface
Because
for
the space
several
ice
hours.
cream, I can't believe that would have been
No.
practical.
No,
It's
well, the
totally-
interesting thing, space ice, the freeze-dried space ice cream was carried on Apollo 7, but it's never been clear if it was actually eaten. There are conflicting reports from the astronauts themselves as to whether it got eaten or not. So it's still an open question as to whether it was ever eaten in space, but even if it was, it obviously was not very popular because it was never eaten again.
Well, it's very crumbly. That's what.
That's right,
Anything
and
that's
that's
crumbly is not good.
yeah, it just shatters.
Causes problems.
But
I think
they
it's
did
tasty.
actually. Sorry, go on.
I would say it's tasty, but at least here on Earth. But
Yeah, but Skylab, they were because they had a freezer on Skylab. And it was launched with a freezer preloaded. They did have ice cream. They had real ice cream because the freezer was preloaded with little ice cream cups that they could eat. But that's the only time. Well, because obviously neither the shuttle nor the ISS has freezers. They've got sort of fridges, but they or something can keep some food cool for short periods, like a cooler, I guess. But they didn't have any kind of freezer, so you can't keep ice cream. But the other thing you were asking about Tang, this is an interesting one because Tang was not, of course, created for the space program, but in the Gemini missions, because the fuel cells were generating the water that they used on Gemini. But the astronauts reckoned that the water had a bit of what they described as a metallic tang. So they didn't like, although that was just happened to be a
bit of
coincidence of the term, but they really didn't like the taste of the fuel cell water very much. So NASA actually started providing the tang to drink with the water. So
make the water drinkable.
Yeah, make the water drinkable. Actually, John Glenn had tang on his flight. But that was sort of a bit of a one-off at that time. But then it became a regular thing. It was regularly available during Gemini and Apollo. Probably on Skylab, I'm not sure about that. But certainly through Gemini. And in fact, I've got a graphic that I found on the internet one time. It's an ad from, a magazine, probably Life or something like that. And it's actually got a big picture of a Gemini spacecraft and a big picture of a bottle of Tang. And the caption with it says, Tang was selected by NASA for the astronauts, and Tang is selected by Mrs. Kafoops for her family, sort of thing. So, in other words, if it's good enough for NASA, it's good enough for Mrs. Kafoops and her family. So, the company that made it made a big thing about the fact that NASA used it, but it wasn't invented for the space program. It just happened to be a convenient way of making the water a little bit more palatable.
Did you see David's comment, Terry, or do you want me to read it out?
Read it out for me.
Okay. David said, thanks for a wonderful presentation, Kerrie. You mentioned lots of aspects of astronaut training, weightlessness, low pressure, use of equipment, etc. But I was wondering what sort of social or interpersonal training they may have received, dispute resolution. What to do if I have an argument, etc. In brackets, Buzz was notoriously a bit tricky to work with.
Well, this is in the early days. Literally, the guys just had to learn to get on. They had no training in any kind of dispute resolution or whatever. But remembering these guys were right stuff. These guys were right stuff pilots, and they knew that if they had to get the job done, they had to get on. As you were saying, Aldrin had a bit of a reputation for being hard to work with, but Armstrong effectively said he had no problems with him. I think Armstrong was the kind of guy that just let it go over him.
Right.
You want to get the job done and that's it. John Glenn was quite like that. He was the sort of, we need to get this done, we just do it. Nowadays, it plays a very big role. Psychological assessment is part of the screening, in the selection process right from the beginning, and a lot of those things, there's a lot of team building type exercises, a lot of that training there for the rescue work and the survival training. All those things are designed not just to teach you how to survive, but to grow people's skills in taking on leadership, becoming confident in their own abilities, learning how to deal with somebody that might be difficult in those situations. There is a lot of role playing and
Okay.
things like that are done to help people develop skills in dispute resolution, and that, of course, they do, as much as possible, attempt to weed out people who may have problematic personalities in the early
I wonder if,
selection.
oh, sorry, Kerrie.
process.
Sorry, I didn't mean to interrupt you. I just wonder
Yeah, no,
whether
go ahead.
in the Orion capsule, the toilet may have helped in this regard, because at least you could have some quiet time out there if you really needed it. You could say, I'm going to be gone for a little while.
Well, possibly, yeah. I mean,
8 days is a long time. I mean, I would have expected to be some squabbles.
yeah. Well, during Apollo, if somebody had the shits with somebody else, they might go down underneath the seats into the seat well
Yeah.
and just have a little quiet time to themselves, or go into the lunar module and just have a bit of quiet time to themselves. It was possible to get a tiny bit of privacy, and as I said, these were guys that knew if they were going to complete the mission and get home in one piece, they all had to work together. Even if you had the shits with somebody, you had to get over that, and you had to continue to work together. That was the only way you were going to get back.
Yeah, I can imagine.
So, it's a little bit different, obviously, with the ISS. You've got a larger group and a multinational group, so everybody does have to work harder at making sure that everybody gets on. I believe there were a few fairly nasty squabbles on some of the Soviet space stations. I think there was at least one mission that ended early when the cosmonauts couldn't get on.
Interesting.
Kerrie, there's a couple of questions above.
Yeah, I'll go. You've got one. Well, it's got one for you and one for Tanas. Okay,
Yeah,
so do
yeah,
yours first about the radiation environment on the space is similar to Trans-Mars, and I think
I did that one already.
She did that.
Yeah, okay. The
Yeah,
other one
I've
is,
answered
what technological and operational changes still need to be achieved before Artemis missions can safely land humans on the moon? Do we have an answer to that yet? Well, we might talk about that shortly and maybe at a future presentation. But
I was going to say,
you can have a go, Kerrie, if you want.
Well, I was going to say, in a word, we still need to know exactly what they'll be landing on Mars, on the moon in. I mean, technically, it's supposed to be the Starship, but of course, we've also got Blue Origin developing their lander as well. And they still, either of them haven't been tested. Starship still hasn't, really completed a satisfactory full mission.
Starship looks inherently unstable standing up.
I tell you something, that's what I reckon too. I'm
doesn't look right.
perfectly open to somebody telling me otherwise, but you need to convince me on it. I mean, the point about the lunar module was it was squat, a good
big span
big stand, so that it could sit and be stable even in a slightly uneven environment. When you're going to the south pole of the moon, where you've got a very rough landing environment,
it's not a football field.
No, I actually really worry about Starship as a vehicle, but especially because it's long and skinny, and you're sitting on top of it, and you're trying to land this long skinny pole on the surface of the moon.
There's an argument going on with NASA and SpaceX over Starship's automatic piloting versus manual at the moment. The Office of the NASA Inspector General has said that NASA is not happy with automated, although there's a debate going on. If you don't want to do the technological and operational, I can quickly answer a little bit about that, but we will cover it as to why. The reason why they have inserted Artemis 3 as a test mission and not a landing mission is there's still too many unknowns
Oh, that's
in
right.
terms of what NASA wants to do. They want to do a rendezvous and docking with one of those vehicles, and they also want to test the spacesuits out. So those are
Yeah.
the two main things that are really are things that they don't really want to leave until a lunar landing to get that to work.
No, well, I mean, this is what they did with Apollo 9.
Well, actually,
They
there's a
had
very
a,
good in the
they had
ignition.
that.
If
Sorry, go on.
Yeah, sorry. If you saw the ignition presentation that they gave, it's actually a slide. They actually try to superimpose the Apollo missions on top of what the Artemis objectives are, and that's why when I suppose you could say Jared Isaacman realised there was a problem with
Yes, that's right.
they're trying to do too many things in one mission, and there's too many things that can go wrong. Okay, so he was worried about the cadence. That's part of the reason why they've tried to change the hardware. I'm going to talk about this in the June meeting anyway, about what's going
All right.
on.
Well, let's leave it to the June meeting then,
But
and
that it will be covered in
take
more
it
detail,
further
so
then.
don't worry
Yeah.
about that. I'm definitely going to do it because it's a big deal. There's a lot of
And it is
unknowns.
yeah. Well, I mean, this is the thing, NASA had Apollo 9 and they had Apollo 10, so they had effectively two rehearsal missions
Yep.
before the landing, and Apollo 11 might not have been the landing if 9 and 10 hadn't been as successful as they were. 12 might have been the landing mission. That was still very much on the cards, even up to Apollo 10. So
There was a concern about the halo orbit as well. With the Gateway, if they were going to try to do that type of thing, the big problem with the halo orbit that they were thinking about doing at one stage with the Gateway was that apparently for an abort, it takes up to a week to get back to the location after you get dropped off, not a matter of hours.
yeah.
The orbit is not really very good for an emergency abort.
Yeah.
So apparently that in itself is almost like really big deal.
Yes.
So something that they hadn't considered.
Well, I mean, I don't think that will I get my tongue around that. Gateway wouldn't have been ready anyway for the
but that's
first landing.
later on,
but
apparently.
yes, in the longer term.
Yeah. So apparently both the two providers are not keen on using that type of halo orbit at all. So they want to do a more conventional orbit like the Apollo, although obviously it's going to be above the South Pole instead of anywhere else. So that's just my
It'll be
comment
polar
on that.
instead of equatorial.
Yeah, that's exactly right. So Vicky's got a question. Psychological assessment and screening, yes, probably plays a big role. That's right in terms of the way the crew selection's operating.
And even then, to be honest, it doesn't always weed out issues. What's his face? Taylor Wang only ever made one space flight because he freaked out at launch, apparently. Despite the fact that he'd been through all his training and everything else.
Right.
But literally at the launch of the shuttle, he apparently freaked out.
Goodness me.
What did the freak out look like? What did he do?
Apparently tried to open the hatch.
No.
Okay, that's not good.
No, that is not good.
It's kind of like
Apparently he had to be, shall we say, chemically restrained.
Kerrie, can I just ask a question? Can I just make a point about that? I'm just wondering. Sorry to interrupt, but I just wondered, the old generation of astronauts, the Apollo missions, they're all ex-Air Force, ex-military.
Yeah, well, they were military pilots.
And of course, they've gone through heavy screening, personality tests, all of those sorts of things. The new, so they're in a lot of ways probably much more disciplined and much more exposed to risk than the new generation astronauts.
Well, many of them had also been in combat as well.
That's right.
Almost all of the early astronauts had flown in Korea.
That's
exactly. Right. So are they finding different? I mean, I would imagine the new generation of astronauts are, heavily screened and heavily trained as well, but maybe not to the same caliber as the older generation astronauts.
I reckon that's a fair call.
Yeah, it's interesting. I mean, I don't know if you can say it's not the same caliber, but I think perhaps the same type of discipline.
Yeah.
If I can make
that
as a fine distinction.
The military way to suck it up, so to speak.
Yeah, exactly. as I said, that when there's a lot more psychological testing that's done now than was done back in the early days, because of course they were looking for primarily the technical skills and the right stuff to have the cojones to actually get on a completely untried vehicle, which is why, of course, Eisenhower wanted from the very beginning wanted test pilots, because these were people who were used to getting into a completely untried vehicle
Yeah.
and making sure that it would work.
Yeah. Yeah.
So, and of course, some of the pilot astronauts now are former military pilots. Some of them have seen combat. Pam Melroy, who was one of the space shuttle female pilots, and of course later the deputy administrator of NASA, she had actually seen combat. She'd combat in the Gulf War.
That would be the first one.
Yeah, so she'd seen combat in the Gulf War. A number of the early shuttle astronauts had flown in Vietnam. More recently, as I said, some of the newer pilot astronauts have had experience in one or other of the Gulf Wars or Afghanistan. So you do still have people coming out of that background, but at the same time, of course, you have a large number of astronauts who do not come out of that background. So I think and I'm open to contradiction here, but I think the psychological screening when you're looking for mission specialists is actually more intensive.
Thomas has put a very good link in the chat here. It says, Taylor Wang, yes, this is mystery. Why did Space Shuttle commanders lock the hatch? That's apparently part of the caption on the link. So for you people, please look in the chat later on. You can find out why they had to do it. And no, I hadn't heard that story until tonight, so that's a new one. So,
yes, well, it's not a publicly known story, I don't think, but I was told it by somebody who was there at the time.
Right. So obviously you've got some spies out that have heard about it. Yeah, well, that's a bit sad, isn't it?
It is very sad, actually. Yeah, but it's a good example of the fact that with all the psychological testing under the sun, you still don't know how somebody's going to react until it happens.
Yeah.
Yes, it looks like it turns out he didn't want to come back. So he launched and then he was representing China, and the experiment that he was working on didn't work. So he felt like a huge amount of shame and became depressed.
He wasn't representing China. He was an American astronaut.
He was an American astronaut, but he was Chinese born.
The whole loss of face thing.
Yes, but
could be Taiwan though, actually, not China, but that's fine.
Yeah, I don't think he would have even been considered to be representing China.
Well, if you look at the quote that he says that, he's talking about Chinese culture and how
Chinese culture is a slightly different thing though from representing China.
Same problem.
Sure. Yeah. So he felt like the shame of that comes with, failing that culture, and that's what made him depressed and not want to come back.
Well, that's possible too.
But
apparently, I get my tongue around this. I think it might have been a compounding thing in that if he failed at liftoff, as it were, he probably didn't do well in whatever, and I don't know, he probably didn't do well on whatever tasks he was supposed to have during the mission itself. So yes, he could very well have been compounding the whole thing by the.
Yes, it sounds like he did.
By the time he got back,
good time with the mission then.
Yeah, but certainly in the end, he never had another flight.
No,
he was removed from flight status.
Well, I guess at least Artemis shows us that Americans and Canadians can get on after all.
By some of the things that are being said at the moment. But I understand Jeremy Hansen, though, was very highly thought of as a pilot anyway. So apparently he had really good credentials. But also the other backup, if you weren't aware of it, and we'll talk about this shortly, was that the two backups, they had one from each country, and there was a rotation. That's why they were picked. And Jenny Gibbons was the backup for Jeremy. I've got a picture of them later on. You might see if you hang around a bit longer. And the other one was Andre Douglas, apparently. He was the backup for the American. So they all had to get the same amount of training.
Well, your backups normally have the they have the same training.
including quarantine. Apparently, they were in quarantine with them as
Oh,
well,
yeah.
just in case something happened at the last minute.
Yeah, well, they learned that one from Apollo 13, didn't they?
Yeah, that's what happened with, Mattingly.
With Mattingly, that's right. So, yes, they've been very strict with the quarantine for the Artemis guys.
Yeah, so there's a selection of Artemis
Girls.
astronauts, not just the. I'll have to go and look up the names, but if anybody, there was some questions asked at the press conference the other day whether they want to pick the Artemis 3 crew, and they said it's coming, but not just yet. So it's something.
Soon was the word.
Yeah, soon. I mean, it's because they only really hadn't finished the current mission, so they've got to probably look at.
McDonald Hazelwood.
Yeah, well, they need to do the.
Yeah.
Sorry?
Balls 15 to 25, they strike at 200. Let's keep doing it from the.
Sorry, my husband doesn't know how to use this.
No, we just got something else there for a minute.
No, I was just going to say they'll need to do the debrief of the current crew to, take whatever lessons learned before they actually make any final
I think
decisions.
so. Then they've got to look at what they're going to do in the next mission, and then try and work out whether they've got anybody who's got
see who
particular
fits
skills
best into the profile.
Because originally it was going to be a landing, and it's not going to be. So it's now got a different mission profile. So that in itself might affect what they're going to do about it.
Somebody's got another question there.
Lou.
Lou?
She's raised her hand. She hasn't actually put anything.
Yeah.
I have to write it all out. Thank you very much, Kerrie. Fabulous talk. I'm just wondering about sleep cycles. How do they work their sleep cycles? Do they take turns, and how their circadian rhythm?
Normally, early on, they tried having like one astronaut awake and one asleep, or one awake and two asleep, whatever. They tended to find that didn't work very well, because the sleeping astronaut would have trouble sleeping if the other guy was awake and perhaps trying to do something, do an experiment or keep himself occupied or talk to mission control or whatever it happened to be. So during the sort of eventually with Gemini and Apollo, both astronauts, or all three astronauts, slept at the same time. With the shuttle, you had because you had the upper deck and the lower deck, you could actually have some separation of a couple of people being awake on the upper deck in the cockpit, while the rest of the crew was asleep, and the lower deck. ISS.
Got their own cabins.
Yes, I gotta say they've got their own cabins. So again, I think there's a bit of a rotation of people who are on and off duty, but they do have, like they have sort of set meal times where everybody does come together so they can share information and that. And I think they all slept at the same time on Artemis, as far as I know.
Okay, thank you.
And I think they'd kind of have to again anyway, because you get back to that old Apollo problem that if you've got somebody awake and mission control's calling up wanting things, whatever, you're going to wake up the other people anyway. In fact, I mean, people certainly in Gemini, Mercury, Gemini, Apollo, and I'm guessing Artemis as well, people don't sleep that well in space. And that's partly because of, all the disturbances to your sort of general disturbances to your circadian rhythms and things. Because, if you're in orbit, you're getting sunrises and sunsets that are changing the light coming into the spacecraft or whatever. A lot of them have to take sleeping pills to get a reasonable length of sleep. So, you're even, on the ISS, the shuttle and that, you'll read of astronauts, complaining about only getting short cycles of sleep, and maybe something disturbs them. They wake up, they can hear the sound of the fans or something just disturbs them, and then it might take a while to go back, even though it's more comfortable to sleep in 0G, because obviously you're not pressing on anything. But certainly some of the astronauts would complain about not getting good sleep anyway. So it's obviously better if everybody's asleep at the same time and there's much less disturbance.
Yep. you. Thanks.
Okay, so
Now, I'm sorry, guys, but I need to go and get some dinner because I haven't eaten yet.
oh, that's great. Well, thank you very much, Kerrie, and
Fabulous, Kerrie.
we've learnt a lot out of this
Thanks, Kerrie.
presentation.
Yep. As long as you enjoyed it, that's the important
Certainly
thing.
Much
did.
appreciated.
It was great, Kerrie. Thank you very much.
Thank you
Yep.
very much.
Yeah,
Very
my
interesting.
pleasure, everyone.